Hello guys, welcome back to my channel again. So today I'm going to discuss about the question about the topic of compound solids in international mathematics. So as you can see here, you will see a question about compound solids. The question says that the rectangle can be made into a hollow cylinder with a height 40 centimeter. Show that the radius of the cylinder is 1.910 centimeter, correct to 3 decimal places. So here the strategy is that we need to have a mental calculation. We need to be able to imagine or visualize the problem here. Okay, and then we move to the next question for the II before I actually explain in details of how to solve this question. So B says that calculate the volume of the cylinder. So in other words, we need to make sure that we know that the value of the radius of the cylinder is 1.910 centimeter before we proceed to find the volume of the cylinder. Okay. Now, as you can see here, the first step is that we need to establish our assumption that the 12 centimeter is the perimeter of the circle. Okay. And then after that, through steps, the first one is that 2 pi r is equal to 12. And then after that, remember the pi is equal to 22 over 7. I think this is like the better idea, the better way, instead of using 3.14, or according to Cambridge, it is better we actually use 3.142. If you really want to keep using decimal, you may use 3.142 instead of using 22 over 7. And then we get third step and fourth step, we get 44r is equal to 12 times 7. And the fifth step says that 44r is equal to 84. And then finally, we get the value of r is equal to 1.909, which is basically, if we round up, it becomes 1.910. And now we move to B, BIB. Basically, this one is actually, we just apply the formula of the volume of cylinder. So we know that the value of the radius is 1.91 or 1.909, and the height is 40 centimeter. And the first step is that we use again pi r square h, 22 over 7 times the radius square, 1.909 or 1.910 square times 40. And then we get the volume equal to 458.138 centimeter cube. Now we move to the question of II. It was stated that the rectangle can also be made into a hollow cylinder with height 12 centimeter. Calculate the difference between the volumes of the cylinder and the cylinder in part I. Give your answer correct to the nearest 10 centimeter cube. Now, the first thing that we need to do is that, like what's actually being stated there, we need to have a good assumption here. Before the first cylinder, it was stated that the perimeter is 12 centimeter. But now the perimeter is equal to 40 centimeter. Therefore, what we should actually find is the value of radius. So the first step is that 2 pi r is equal to 40, pi r is equal to 20, and then we find that the second radius of the second cylinder is equal to 6.363 centimeter. And then after that, we apply the formula of the volume of the cylinder, pi r square h. So we find the volume is equal to 1526.967 centimeter cube. Now, remember, this is a question that actually has 4 points. Some of my students actually just finish until finding the second volume, which is 1526.967 centimeter cube, without finishing or without answering the main question. The main question is actually finding the difference between those two volumes. So what we should do is that we subtract them, in which that 1526.967 minus 458.138 centimeter cube. So we've got the difference between the volumes is 1068.829, or we actually round it up, become 1068.83 centimeter cube. Now we move to the last part of the question, the B. A model of a car is mathematically similar to the actual car. The volume of the model is 75 cubic centimeters and the volume of the actual car is 4.8 cubic meters. The scale is model compared to the actual is equal to 1 over n. Find the value of n. Now, to answer this question, we need some good strategies here. Now, first of all, is that we need to remember that the common flaw in this type of question is that we just convert the bigger values, in this case is 4.8 cubic meters, and put them into ratio. This is a fatal move. So as you can see that most of my students actually they actually have a good analysis here. They already have the starting point here, but they forgot about the properties of volume of the volume of solids. So 4.8 meter cube, we convert into 4.8 times 10 power of 6. So we've got 4.8 times 10 power of 6 centimeter cube. And then they divided in 75 centimeter cube compared to 4.8 times 10 power of 6 centimeter cube. And then they found that the model compared to the actual is equal to 1 over 64,000. While the truth is that we need to remind ourselves that the concept of volume, for example, the volume of cylinder, is equal to pi r square h. There's the idea of pi times r times h. The r is the first component, the other r is the second component, and the h, the height, is the third component. It's also the same thing with cube weight. The volume of cube weight is equal to side cube. The first side is the first component, second side is the second component, and the third side is the third component. The same thing also with the sphere. In other words, we need to do, in the first step, if you see, the model compared to the actual is equal to, we need to use the idea of cube root. This is very important, guys. So the cube root of 75, which is the model, compared to the actual is the cube root of 4.8 times 10 power of 6. Since both of them in the cube root, then what we can do is that we just combine them. Unless if they are actually one actually cube root and the others is square root, we cannot make we cannot combine them. Okay, but in this case, since they are actually in the cube root, we can actually combine them. And then as you can see in the fifth step and the sixth step, I divided by 3, and then we have 25 over 1600 times 10 power of 3. And then we can actually divide them again by 25, and then 25 divided by 25 is equal to 1, and 1600 divided by 25 is equal to 64. The cube root of 1 is 1. Of course, it's obvious. And the cube root of 64 is equal to 4. And then that's what we've got. The result is 1 compared to 40. That's the ratio between the model compared to actual. Okay, see you guys for my next discussion of international mathematics. God bless you.